And welcome back. Here's the conclusion of Module 6, which is finding probability using tables. All right, so here we have a contingency table. This is a table of degrees received in thousands, don't worry about the thousands, in the United States during the 08-09 academic year. All right, so we have female, male total, bachelor's, master's, professional, doctorate, and total. So if you add up all the numbers in the first row, you should get 1481. If you add up all the numbers in the second row, you should get 1025. And if you add up all of these all totals, you should get 2506. So we should first double check that those numbers are correct. So if I add 1679 plus 671 plus 97 plus 59, 2506, good. 986 plus 693. Okay, looks good. So the rest of it's probably correct. All right. So we can ask the following questions. We can ask, if the degree recipient was chosen at random, what is the probability that the recipient, and then all of these ones. So notice it says a degree recipient. So we're talking about a single instance here, right? A single instance. So if we were interested in finding out what's the probability that she was a woman, we look to see the female row. There were a total of 1481 women. Okay, so the probability rule states that we would take the 1481, the number of women, and we divide by the number of elements of the sample space. So since it was out of all the people possible, that was 2506. We're looking at 59.098, so 59.10%. Okay, so 0.5910. Now, what you'll notice on these is you're going to have to keep typing in that 2506. So what I'm going to do is I'm going to take 2506 and I'm going to hit the store button. I'm going to store that as a letter. So click the alphabet button. You'll see an A blinking, and we'll save that as letter A. Okay. So now anytime I type letter A on the keyboard, I can do Shift A, or I can do alphabet A, which is the math key. Then it will use the 2506 that I've stored. Okay. So what is the probability that the selected person was male? Find out how many total were male, so 1025. And then divide by A. So 40.90%. 40.90% here. Received a master's degree. So how many people received a master's degree? 671. So I can do 671 divided by A. 26.78%. 26.78. And by the way, we can write all of these as fractions as well. So in the case of the woman, the fraction equivalent was 1481 out of 2506. And sometimes it's advantageous to just leave the answer as a fraction. So I will try to make this clear on the exams and the quizzes when I want it as a fraction and when I want it as a percent or a decimal. Okay? For now, we're just giving the answers as decimals. All right. Male or received a master's degree. Male or master's. All right. So there were that many people that were male, 1025. That's how many men there were. And there were that many master's degree candidates, 671. So do I just add the 1025 and the 671 and then divide it by 2506? Well, remember that since it's a single selection, we have to ask if they're disjoint. Well, they're not disjoint because that's how many are in the intersection. There's 260 men who received masters. So if you're counting these 671 and if you're counting these 1025, you're counting the 260 twice. So what we have to do then is we have to go the 1025 plus the 671, but then take away the 260 because you've counted it twice. You're only taking away once, right? So 1436 divided by A gives you 57.30%. 57.30%. So in other words, about 57.3% of the people who were in this study were men who received a master's degree. Okay, men who received a master's. All right, male and received a master's. So and meaning the events occurred at the same time. So that would just be this number right here. So the advantage of these tables is sometimes you can just get the answer right from the table. So that's the numerator. The numerator is 260. The denominator, once again, is 2506, which is our letter A. 10.38%. 10.38%. Okay. How about not male and did not get a master's degree? This is a little bit trickier. So let me erase the slides again. All right. So not male implies female, right? So this is the number that we're not male. But we're also interested in those people that were female but also did not get a master's degree. So that's these people, these women, and these women. So the 986, the 52, and the 32 are the ones that we're talking about because those people did not get a master's degree and they're female. Okay, so we would go 986 plus 52 plus 32, and then so 1,070 women who did not get a master's, and then divide that by, once again, A. So 42.70%. Okay. Is either female or male? Well, according to the table, all of them are either female or male. So if we're going to do it mathematically, you would simply just do 1481 plus 1025 divided by 2506. But if you think about it logically, of course, the answer is 1. In other words, 100% of all of the applicants are either female or male. Finally, what's the probability that the applicant received a bachelor's degree given that the recipient was a woman? So the denominator is not going to be 2506 anymore, okay? The denominator is going to be this number, the 1481, because we're now assuming that the applicant was female, so we can now ignore these people, okay? So bachelor's degrees were here out of the females, and the total were here, so that's going to be the numerator here, and that's going to be the denominator here. So that's how we calculate that number. So 986 divided by 1481 is 66.58%. And that concludes this presentation.